This is my presentation about efficient unit testing. This is a four-part module course, which we have four videos where we discuss different characteristics of efficient unit testing. In the first part, we will see some basics, some theory. Then in the second part, we will have some basic unit test. In the third part, we will have some mocks. Just a moment. We'll have basics, unit tests, some mocks and stubs. And in the last part, we'll see some qualities of test coding and clean test code especially. Okay. So first of all, why do we need testing? So if you know your software is working, it's a lot easier to deliver software. If you don't know your software is working, it's a lot easier to not deliver software. So how do you ensure that your software is working? Of course, through testing. So what testing options do we have? So first of all, we have the QA department testing, the testers we refer to in the development team, and the automated tests which are written by developers. Good. So let's see the, the advantages of QA department testing. So the startup time costs are very low. They can test right away. They can test the UI code easier, and they can think of different things to test compared to we as developers. The disadvantages: it's time intensive, it's not so efficient, and could become frustrating in some cases. The automated unit tests, which are written by developers, they are fast, they give us immediate feedback, they are repeatable, and they have a good code coverage. And the most important thing, they are fully automated. The disadvantages: they take more time upfront, and the quality is only as good as the developer who writes them. And yeah, they are hard to test the UI. So QA department and or unit testing. So let me be clear. So unit testing doesn't eliminate QA related jobs. So the QA guys, instead of doing UI debugging with clicks and see if something breaks, they can focus on finding more logical bugs in the application. So this is exploratory testing, which is also very important. So the unit tests provide the first layer of defense against bugs, and QA provides the second layer of defense, the user acceptance layer. So allowing QA to focus on larger issues will provide better applications. Good. What is a unit test? A unit test is a method that instantiates a small portion of our application and verifies its behavior independent from other parts. So what is a unit? Is a unit of work or a use case inside a system. When you're testing something, you refer to the thing you're testing as the system under test. So we have an input, we trigger something on the system under test and observe its outcome. The unit of work is a sum of actions which takes place between the invocation of a public method usually and a single noticeable result. So the unit can span a single method or multiple classes and functions to achieve its purpose. So what is the result of such a unit of work? It's a value, a state, or an interaction. So here we see a chart um, with most of the time we check a value which is returned from a unit of work. Then we can return a state, for example, in case of a state machine where system properties change, or an interaction. This is not so often used, but this happens in case of third-party control systems, for example, when we don't have control over what it is returning. So we test that something was called in that third-party component, for example. So why would we test code? So to improve the quality and get immediate feedback after doing some code changes, to have some more error handling and be able to refactor code more easily and to be more confident. And the side effect, you break the code into smaller chunks, which leads to more maintainable systems in the future. So this is not good for unit testing, but also for the application, which is much more better and understandable. Good. Here's the difference between unit testing and integration testing. We should draw here a clear distinction. So these are the testing strategies. So we have unit testing, integration testing, and UI testing. These are mostly done by QA department, and these two are mostly done by the developer team. Here you can see the unit tests are more faster, the other are slower, and the unit tests are cheaper, and the other tests are, as it goes to the delivery process, the tests are more expensive. Integration tests, they use one or more real dependencies. Um, so, for example, if a test uses a real-time system time or the real files or a database, that is a integration testing. Integration tests are also very important and important counterparts to unit tests, but they should be separated from them. I recommend using a different project for integration testing as unit tests. So the downside of integration tests, they takes longer to execute, they need more configuration, takes longer to understand by other team members. That is very important because if not all persons from the team understand your tests, and especially integration tests, then it's harder to have a high quality software which is maintained by all developers. They are harder to write, the feedback loop takes longer because they take longer to execute and are harder to maintain. So what happens when a unit test is or an integration test is hard to maintain? They are not maintained, okay? So here's again the difference. The unit test verifies the behavior of a relatively small piece of software independently from other parts, whereas the integration test demonstrates that different parts of the system works well in the real-life environment. They validate complex scenarios and usually require external resources like databases or web servers to be present. What I would recommend is to have a reasonable combination of unit tests and integration tests to ensure that every single unit works correctly independently from others and that all components works well together. Okay. Here we will see just a funny video. So here we'll have a unit test. Okay, it works fine, the lock, and now the integration test fails. So that's it, why it's important to have also unit tests and also integration tests. Good. Let's focus now on unit tests and see some qualities of efficient unit testing. Yeah, they are clear and simple. They provide a high value. We should not write unit tests if they don't provide a high value, right? And they should be flexible to be easy to change, and not every time we change the production code we have to come back and change for every minor change also the unit test. It should be flexible. What makes a good unit test? It should be readable, should be clear to all developers, it should be hard to find the problem why it fails, and ideally we should find the bug without actually debugging code. Unit tests should be independent. They should not depend on each other. One test should not set up the condition for the next test. You should be able to run each test independently and run the test in any order you like. They should be fast. They should be fast. So when the test runs slow, you don't want to run them. You also have to run them frequently. And if you don't run them frequently, you won't find problems early to be able to fix the issue. They should be professional. Um, in the long run, you'll have as much test code as production code, maybe even more, and follow the same good design decisions. So to have a good intention revealing names, no duplication, tests with good names, etc. And the unit test should be really unit tests and not integration tests. They have different purposes, but if you have unit tests and integration tests, please separate them into different projects. A good unit test follows the AAA pattern. It contains three phases. The arrange. First, it initializes a small piece of an application, the system under test, and for example, create objects, prepare inputs, and configure mocked interfaces. Then we have the act. This is where we perform the actual work of the test, typically by calling a function, and the assert, where we verify that the unit under test did what you expected. Unit test should have high precision. That means a unit test, if it fails, it should point us directly to the problem. Um, it should test exactly one expectation per test. It can multiple asserts, but only against the same object. And as I said, should point you to the precise location of a problem in case it fails. So here's an example of how you would refactor a bad unit test into a good one. So basically we have a unit test. The naming is also not so good of unit test. Review save state. What tells us this? Nothing. So here we assert against three objects: the result, the input, and the we check here something else, mock assert. And these are three expectations. And what we should do in this case, we should separate this unit test into three tests with well-defined names. This looks much more better, and if such a test fails, you can know exactly what went wrong. So we have three tests which are much more granular and easier to understand.